Hello class, welcome to Supply and Demand Lesson 6. This one is on the algebra of supply and demand curves. So if you just think about it graphically, there are algebraic expressions that describe demand curves and supply curves, and I've created a couple of simple ones. So instead of just writing the demand curve, let's write quantity demanded equals 50 minus 2p. Instead of the supply curve, we have quantity supplied equals 3p minus 15. You can always tell a demand curve because it has q on one side and p on the other, and there's always a negative sign on the coefficient on p because when price goes up, quantity demanded needs to fall. Supply curve, same basic idea, you have q on one side and p on the other, but in the case of the supply curve, there should be a positive sign on the coefficient on p because as p goes up, quantity supplied increases. Alright, so if you want to find the equilibrium price, it would be 13, and I'll show you in a minute how to do that, and the equilibrium quantity would be 24. Here's how you would do it. To find the equilibrium price, you just start with the definition of the equilibrium price, which is the place where quantity demanded equals quantity supplied. So you just write this as step 1. Step 2, you substitute what these things are. So QD is 50 minus 2p, and QS is 3p minus 15. So here's the line where I've done that substitution. Now we just solve by adding 15 to both sides, and at the same time adding 2p to both sides, and I get 5p equals 65. Then dividing both sides by 5, I get p is 13, and that's where this came from. To get the equilibrium quantity, you just need to remember that the equilibrium quantity is defined to be the quantity demanded or the quantity supplied at the equilibrium price. So there are two ways to find the equilibrium quantity. You can find it from the QD equation or from the QS equation. So let's do it both ways. Starting with the quantity demanded equation, I just write it out, but instead of writing the p, instead of writing this p value, I write the equilibrium price, which we've already calculated, which was 13. So the quantity demanded is 50 minus 2 times 13, or 50 minus 26, or 24, which was this number right here. Now we can do it also from the supply equation, writing out the supply equation here, but instead of writing the p value, I put the equilibrium price, which was 13. So 3 times 13 is 39. 39 minus 15 is again 24. Notice that whether I solve the thing from the quantity demanded equation or from the quantity supplied equation, I get the same number, 24. Now there's a few other questions that I could ask you. Consider this. What would happen if this product was offered for free? So if we offered this product for free, you got to think about the demand curve. How many would people want? It would be down here someplace, so I'm going to just kind of extend this axis, and now I'm looking for this place. Algebraically, I'm looking for the quantity demanded where the selling price is free, or to put algebraically, where the selling price is 0. So just sticking a 0 in for the selling price, I get QD equals 50 minus 2 times 0. 2 times 0 is 0, so QD equals 50. That'd be this number right here. Let's try another one. How high could the price go before consumers would buy nothing? Again, that would be up here someplace. As the price gets higher and higher and higher, quantity demanded gets less and less and less, and way up here, at this spot right here, the quantity demanded would be 0. So I write the equation, but in this case, I just set QD equal to 0 because I'm looking for the price that makes the quantity demanded 0. Now I'm just going to solve the simple equation by adding 2p to both sides. Then p is 25. So this number up here is 25. Alright, let's try one more. How low could the price go before producers would decide to produce nothing? So you think about the supply curve. As the price gets lower and lower and lower and lower, quantity supplied gets less and less and less until finally they don't produce anything, which would be right over here someplace. So I'm looking for this place algebraically. So you would just write the equation for the supply curve, QS equals 3P minus 15. But of course, I'm looking for a price where this thing over here is 0. I want the quantity supplied to be 0. So just sticking a 0 in there. I'm going to solve this thing by adding 15 to both sides and dividing both sides by 3. I get P is 5. So this number right here is 5. If you think about it, a price ceiling, a price floor, pretty much anything that you can visualize on this graph can be solved with simple algebra. Any question that can be illustrated graphically can be solved algebraically. Okay, so the next lesson is on multivariable demand curves. Hope you found this helpful.